Good day, grade 11 students. Welcome to Bamboo Telescuela. This is your school on air in General Mathematics. I am Sir Lyndon. Before we continue, make sure to grab with you your modules 1, 2, 3 and tune into DWND FM and CMD Cable Channel 1. Also, this video is streamed live at SDO Cauayan Facebook page. Today, we are going to unleash your mathematical potentials as we begin our first competencies in general mathematics. In this lesson, we are going to first represent real-life situation using functions, second, evaluate and perform operations on functions, and third, solve problems involving functions. Are you ready? Let's start. In our first activity, we are going to differentiate function and relation by correctly choosing the description that better fits the two terms. First, it is a rule that relates values from a first set of values called the domain to a second set of values called the range. And second, each element in the domain is related to only one value in the range by some rule, which is function and which is relation. That's correct. On my left, this is the definition of relation, while on my right, this is the definition of function. Second set. The elements of the domain can be imagined as input to a machine that applies a rule to these inputs to generate one or more outputs. On the other hand, the elements of the domain can be imagined as input to a machine that applies a rule so that each input corresponds to only one output. On my left, this is the definition of relation, while on my right, this is the definition of function. Finally, as you can see in your screen, it is a set of ordered pairs xy such that no two ordered pairs have the same x value but different y values. While on the right, it is also a set of ordered pairs xy. On my left is the definition of function, while on my right is the definition of relation. Next, in our second activity, given sets of ordered pair, we are going to classify if the set illustrates a function or not. Here are the items. Which of the following relations are functions? Is it number 1, number 2, or number 3? The relations which are functions are numbers 1 and 3. On the other hand, for number 2, it is merely a relation because there are some terms or there are some values in x which are duplicated or triplicated. For instance, we have 1, 1 and 2, 2. Not only can we determine relations and functions by definition or by sets, because they can also be represented by mapping diagrams where the elements of the domain are mapped to elements of the range using arrow. For instance, in our first map, 1 is mapped to 3, 2 is mapped to 5, 3 is mapped to 11, 4 is mapped to 9, and 5 is mapped to 33. This mapping is classified as one-to-one function, in which every element in the domain is mapped to a unique element in the range. For our second diagram, 5 is mapped to 1, 6 is mapped to 0, 7 is mapped to 1, 8 is mapped to 0, and 9 is mapped to 0. This is classified as many-to-one function, in which two or more elements of the domain are mapped to the same element in the range. For our last example, 7 is mapped to 13, it is also mapped to 11. 2 is mapped to 13, and it is also mapped to 19. And 1 is mapped to 23 as well as to 17. And this is classified as one-to-many relation. It is not a function because one element such as 7, 2, and 1 are linked to many elements in the range. For our last part, we have vertical line test, in which a graph represents a function if and only if each vertical line intersects the graph at most once. For instance, if we have the graph of sine x, any vertical line will only pass through the graph once. Also, if we have parabola opening upward, this will satisfy the vertical line test. A certain line can also satisfy the vertical line test. However, if we have the graph of a circle, any vertical line can pass the graph once or twice. Therefore, it does not satisfy vertical line test. And also, if a parabola opens to the left, it will not satisfy the vertical line test. Therefore, the graph is not a function. It is only a relation. This time, we are going to try to represent real-life situations in functions. For example, give a function c that can represent the cost of buying X meals if 1 meal costs 40 pesos. Before we represent the situation, let's try to illustrate it. Suppose you are going to buy 1 meal. Therefore, that will cost 40 pesos. If you are going to buy 2 meals, you are going to pay 80 pesos. 3 meals, 120 pesos. Therefore, if you are going to buy X meals, then you are going to pay 40X, where X represents the number of meals you are going to buy. Is it clear? That's great. Now, not only can we represent functions, we can also evaluate a function, which means replacing the variable in the function with a value from the function's domain and computing the result. For our first example, we are going to evaluate the function f of x is equal to x squared plus 3x minus 2 for each replacement of x. So we have the values of x as negative 3, 0, 2, and 3. For letter A, if x is equal to negative 3, then f of negative 3 is equal to the square of negative 3 plus 3 times negative 3 minus 2. Simplifying further, we have 9 minus 9 minus 2, which is equal to negative 2. Therefore, f of negative 3 is equal to negative 2. For letter B, if x is equal to 0, then f of 0 is equal to 0 squared plus 3 times 0 minus 2. Simplifying further, we have 0 plus 0 minus 2, which is equal to negative 2. Therefore, f of 0 is equal to negative 2. For letter C, suppose x is equal to 2. This means that f of 2 is equal to 2 squared plus 3 times 2 minus 2. Simplifying further, we have 4 plus 6 minus 2, which is now equal to 10 minus 2. The final answer is equal to 8. Therefore, for letter C, if x is equal to 2, then the function is equal to 8. For letter D, if x is equal to 3, then f of 3 is equal to 3 squared plus 3 times 3 minus 2. Simplifying the result, we have 9 plus 9 minus 2, which is equal to 18 minus 2. The final answer is 16. This means that if x is equal to 3, then the value of the function is equal to 16. Did you get it? Very good. For our second set of example, there are 4 problems here, or there are 4 functions in which the value of x is equal to 3. Now we are going to evaluate the 4 functions if x is equal to positive 3. For the first function, we have f of x is equal to x minus 3. Therefore, f of 3 is equal to 3 minus 3, which is equal to 0. This means that f of 3 is equal to 0. For our second example, we have g of 3 is equal to 3 squared minus 3 times 2 plus 5. Simplifying further, we have 9 minus 9 plus 5, which is equal to positive 5. Therefore, the value of the function is equal to 5 if x is equal to 3. For the third example, we have h of 3 is equal to cube root of 3 cube plus 3 plus 3, which is equal to cube root of 27 plus 6. Final answer, cube root of 33. Therefore, h of 3 is equal to cube root of 33. For our last function, we have n of 3 is equal to 3 squared plus 1 all over 3 minus 4. If you're going to simplify it, the answer is negative 10. Therefore, n of 3 is equal to negative 10. I hope you are still with me in evaluating functions. For our final example in evaluating functions, we are going to evaluate f of a plus b, where f of x is equal to 4x squared minus 3x. This means that the value of x is equal to a plus b, which is equal to 4 times the square of a plus b minus 3 times a plus b. But before we continue, let's recall that the square of binomial, or the square of a plus b, is equal to the square of the first term plus twice the product of the first term and the second term plus the square of the last terms. Meaning, f of a plus b is equal to 4 times the quantity a squared plus 2ab plus b squared minus 3 times the quantity a plus b. Simplifying further, we are going to distribute 4 to the trinomial and negative 3 to the binomial, which is equal to 4 times a squared plus 2ab plus b squared. So we have 4a squared plus 8ab plus 4b squared minus 3a minus 3b. To simplify this result, we are going to check if there are terms which are similar. Since there are none, we will just arrange the terms in descending order. So the final answer is 4a squared minus 3a plus 8ab minus 3b plus 4b squared. And that is the answer of our last example. Since you are now prepared to identify or to evaluate functions, we are going to apply your knowledge in solving problems related to functions. For example, Mark started selling snacks in the nearby school. In one day, he spends 200 pesos for rent and 25 pesos for each snack item he prepares. His expenses in a single day can be expressed as the function c of x is equal to 25x plus 200, where x is the number of items and c of x is his daily expenses in pesos. How much are his expenses if he prepares 100 snack items? For our solution, we are going to let x be the number of items and c of x be the daily expenses of Mark. Since, according to the problem, how much are his expenses if he prepares 100 snack items? Meaning, x is equal to 100. So we are going to evaluate the function at x is equal to 100. Simplifying further, we have c of 100 is equal to 25 times 100 plus 200. 25 times 100 is 2,500 plus 200 is equal to 2,700. Therefore, the daily expenses of Mark if he is going to prepare 100 snacks is 2,700 pesos. Did you arrive with the same answer? Then congratulations! For our next problem, the function for the height of an object dropped from a 100-meter tall platform at a time t seconds is approximated by s of t is equal to negative 5t squared plus 100. The question is, what is the height of the object after letter A, 2 seconds, letter B, 4 seconds? For our solution, in letter A, we are going to let t is equal to 2. This means that s of 2 is equal to negative 5 times the square of 2 plus 100. The square of 2 is 4. Negative 5 times 4 is negative 20. Negative 20 plus 100 is equal to 80. Therefore, the height of the object is 80 meters after 2 seconds. On the other hand, if t is equal to 4, s of 4 is equal to negative 5 times 4 squared plus 100. If you are going to simplify it, the result is 20. Therefore, the height of the object is 20 meters only after 4 seconds. If you can notice, the height of the object after 2 seconds is higher than the height of the object after 4 seconds. Why did you think so? Yes, that's right. It is because the object is dropping. Therefore, as the time increases, the height of the object also decreases. For the last part of our lesson, we are going to perform operations on functions. This means that we are going to add, subtract, multiply, divide, and find the composite of functions. Let f and g be functions. Their sum, denoted by f plus g, is the function defined by f plus g of x is equal to f of x plus g of x. On the other hand, their difference, denoted by f minus g, is the function defined by f minus g of x is equal to f of x minus g of x. For example, if f of x is equal to x squared minus x minus 2 and g of x is equal to x plus 1, we are going to find the quantity f plus g of negative 3. To solve our first example, first we need to evaluate the functions f and g if x is equal to negative 3. So f of negative 3 is equal to the square of negative 3 minus negative 3 minus 2. Simplifying further, we have the final answer as 10. On the other hand, we have g of negative 3 is equal to negative 3 plus 1. Negative 3 plus 1 is equal to negative 2. Since we already know the functions f of negative 3 and g of negative 3, we are now ready to identify our final answer. To do this, we have f plus g of negative 3 is equal to f of negative 3 plus g of negative 3. F of negative 3 is equal to 10, g of negative 3 is equal to negative 2, 10 plus negative 2 is equal to positive 8. So our answer is positive 8. For our second example, we have f of x is equal to 2x minus 4 and g of x is equal to x squared minus x plus 5. We are going to find f minus g of x. This means that we are going to subtract f of x to g of x. Note that g of x should be the subtrahend. By rules of subtraction, we need to change the sign of all the subtrahend and proceed to addition. We have 2x minus 4 minus the quantity x squared minus x plus 5. So 2x minus 4 minus x squared plus x minus 5 is equal to negative x squared plus 3x minus 9. Final answer, we have negative x squared plus 3x minus 9. In our first set of examples, we have added and subtracted functions. Now we are going to multiply and divide functions. For the third example, h of x is equal to 2x minus 4 and k of x is equal to negative 3x plus 1. We are going to find h times k of 5. To find h times k of 5, we have to separately identify h of 5 and k of 5. H of 5 is equal to 2 times 5 minus 4, which is equal to 6. On the other hand, k of 5 is equal to negative 3 times 5 plus 1. If you are going to perform the operation, we have negative 14. If h of 5 is equal to 6 and k of 5 is equal to negative 14, all we have to do is to multiply the two numbers. Therefore, h times k of 5 is equal to h of 5 times k of 5. 6 times negative 14 is equal to negative 84. Therefore, the final answer of our third example is negative 84. For our final example, f of x is equal to x squared minus 4x minus 5. G of x is equal to x minus 5. We are going to find f over g of x. This means that we need to get f of x over g of x. We have x squared minus 4x minus 5 all over x minus 5. If you are going to remember your lesson in factoring, the factors of x squared minus 4x minus 5 are x minus 5 and x plus 1. Hence, we can cancel x minus 5 in the denominator. Our final answer is x plus 1. Now we'll have compositions of functions. Let f and g be functions. The composite function is defined by f of g of x is equal to f times g of x. This means that the value of x in the first function is equal to the second function. And the process of obtaining a composite function is called function composition. For instance, we have f of x is equal to x squared minus x and g of x is equal to x plus 3. We are going to find f of g of x. This means that we are going to substitute the value of x in the first function into the second function. To do this, we have f of g of x is equal to the square of x plus 3 minus x. the square of x plus 3 is x squared plus 6x plus 9 minus x plus 3. Simplifying further, we have x squared plus 6x plus 9 minus x minus 3 is equal to x squared plus 5x plus 6. So our final answer in our first example, we have x squared plus 5x plus 6. Now let's verify if there is a difference if we are going to find g of f of x. Given the same functions, we are going to analyze if there will be a difference if we are going to switch the two functions. This means that we have x squared minus x plus 3, which is equal to x squared minus x plus 3. If you have observed, our first answer is different to our second answer. Therefore, in composite functions, the order matters. Always remember that by convention, the x variable is the input variable and that the value of the y variable is computed based on the value of the x variable, just like in a simple machine. Also remember that a relation is a function if for each x value there corresponds only one y value. And we have covered the first chapter of general mathematics. We have studied functions as models, evaluating functions, and operations and compositions on functions. Before I end this video, let me remind you that according to Albert Einstein, it's not that I am so smart. It is just that I stay with problems longer. Till next time, grade 11 students, mabuhay!